All around us, there are these invisible forces at work silently attacking the very structures we rely on every single day. So today, we're going to expose two of metal's most persistent and hidden enemies.
Okay, take a look at this. I bet you've seen something just like it, right? Maybe on a boat, a pipe, or even a bridge support. But have you ever really stopped to ask, what invisible force is actually causing that kind of targeted destructive damage?
Well, the answer is a process called corrosion. And in this explainer, we're putting two really specific and honestly fascinating types of it right under the microscope to see how they tick. Now, it's super easy to just call this rust, but that's not the whole story, not even close. What we're really talking about is a silent electrochemical attack. It's like a tiny, invisible battery forms on the metal surface, and it literally just eats it away, weakening it from the inside out.
All right, so let's meet our two main culprits. Think of them as villains in this story. First up, we've got Waterline Corrosion, and its sneaky partner in crime, that would be pitting corrosion. They each have their own unique way of doing damage, and figuring out their playbook is the first step to actually stopping them.
Okay, so first up is Waterline Corrosion, and its name pretty much gives the game away, doesn't it? This attack happens in one very specific place, right at the waterline. That exact line where the air, the water, and the metal all come together. Just picture the hull of a ship or a post sticking out of a lake.
And then there's its accomplice, pitting corrosion. This one is way more surgical. Yeah, that's the word. Instead of this broad attack, it creates these tiny, deep holes, pits. Honestly, on the surface, it might not look like a big deal at all, but that damage can go surprisingly deep.
So the big question is, how do they actually pull this off? How do they do their damage? Let's get into the nitty-gritty and break down their methods of attack.
Waterline corrosion? It's a total opportunist. It absolutely thrives right there at the surface because that's where you get this big difference in oxygen levels. You've got tons of oxygen hitting the metal above the water and way less for the metal just below it. And that difference? It basically creates a natural battery on the metal, supercharging the corrosion process right along that one line.
Okay, but pitting is a whole different beast. If waterline corrosion is an opportunist, then pitting is an assassin. It finds one tiny, microscopic weak spot and just focuses all of its destructive energy right there. The result? Deep, penetrating damage that starts from what looks like a completely insignificant little speck on the surface.
The way it works is kind of like a three-act play of destruction. Act 1, a tiny, almost invisible crack happens in the metal's protective layer. Act 2, that little exposed spot suddenly becomes electrically active. Scientists call it an anode, and that's what kicks off the corrosion. And from there, it's Act 3. A vicious cycle starts, and the pit just burrows deeper and deeper, all while being almost completely hidden from view.
All right, let's put this side by side. Waterline corrosion, it's all about that one specific location, the air waterline, and it's driven by that difference in oxygen. What you see is a clear horizontal line of damage. Pitting, though, that can pop up anywhere there's a tiny flaw, and its calling card is those small, deep holes. The easiest way to remember? One's a line, the other's a dot. Simple as that.
Okay, so this isn't just some textbook science stuff. This is happening all around us right now. So where are the crime scenes? Where can we actually find these two culprits at work? Let's go take a look.
You'll spot waterline corrosion all over the place, on ship hulls, on bridge supports sticking out of the water. Pitting, though, that's a huge problem for things like industrial water tanks and underground pipelines. And get this, it can even show up in your stainless steel kitchen sink if you let things like salt or certain cleaners sit for too long.
And the cost of all this? It's staggering. We're not talking millions. We're talking billions of dollars, with a B. Billions in damage, repairs, and replacements every single year all over the world. It's a massive, massive problem for our economy and, more importantly, for our safety.
But hey, it's not all doom and gloom. This isn't a losing battle. We've actually come up with some incredibly clever ways to fight back. So, what's in our arsenal? What does our defense against this decay actually look like?
Well, we have a whole range of strategies. The first line of defense is often something simple, like a good protective coating. Think paint or epoxy. For bigger threats, we use this really cool trick called cathodic protection. Basically, you attach a different, more attractive piece of metal to whatever you're trying to protect. The corrosion goes after that piece instead, sacrificing it to save the main structure. It's pretty genius. Of course, there's also just picking the right corrosion-resistant materials in the first place, using special chemicals called inhibitors to slow things down, and, good old-fashioned regular checkups.
Look, at the end of the day, it all boils down to one thing. Whether you're an engineer designing a billion-dollar bridge or just someone trying to take care of a boat, understanding how, where, and why these things attack, that is the absolute first, most critical step to defeating them.
So, that leaves us with one final thought. We've just pulled back the curtain on two invisible enemies that are constantly attacking our world. It kind of makes you wonder, doesn't it? What other invisible forces are out there, quietly shaping the world around you, right at this very moment?